has a big motor in it, and we can show you exactly what it will do on that particular demo kit. So then I'll go over the rest of it. So it's not a lost cause. Good thing I have my demo kit over here. It'll be here in a minute.
No, he had to go. He's used to keep borough management of the town, so he's like up to here.
Everybody here?
Is everybody ready?
Yeah. That's
Okay.
all. First of all, thank you guys for showing up today. I apologize. We've been in a lot of buildings already today, and the past 2 days we've been all over the place. We just got back from a great big industrial plant, and they are so impressed that they're wanting a sizing done on their facility naturally. What we just did for them, we took went in where they had the big chiller units and everything in this big industry, and we were looking for something to give them a demo with on their sizing gear, which is, this is what is going to set us apart. I'll explain this in just a minute. This little guy, we've been hauling that thing all over the country. It's quite heavy, 65 pounds big today. But anyway, we found a panel box that's about a 6-foot panel box. We pulled the lid on it with the electrician, and we hooked that unit up. And if you're familiar with power factor correction, first of all, let me kind of give you a quick overview on what this is. This is a set of capacitors in these boxes, and what they do, they filter out what we call line noise. Line noise is 20 to 30% of line noise is wasted electricity that you pay for every single month. The best analogy of line noise is this. If the bartender over here got us a draft beer, we had about that much foam on top of it, he would charge you for a full glass of beer. Problem is, if you let it sit long enough, you're going to find out he kind of ripped you off, and you only got about 3/4 of a glass of beer. The electricity company does exactly the same thing. Your motors in your buildings create line noise, and that would be the foam on top of that beer. So you're paying for that foam. It's useless energy. It creates what I call false amperage. It makes your amperage go up as it goes out to the meter. I'll explain that in a minute, exactly what I mean by that. So if we filter that off and get rid of the foam, now you're simply paying for exactly what you're using. So if we're going to get a glass of beer, we're going to pay for 3/4 of a glass instead of a full glass.
Can I ask you a question?
Yes, sir.
How do you do that? Not at the source, but after it already comes into the building?
We do that at the source of the motors.
Okay.
The best, and that's great questions, and we'll answer a lot of questions for you at the end of this. Let me give you a quick demo first. And this little meter, this little blue meter, is registering what we call EMF in this building right now because we're plugged into the electricity. It's setting at about 1550, 1600. It's fluctuating. It's called microsurges to some people. It's called EMF, electromagnetic field radiation, to some people. I call it line noise. That's my analogy of it. So you're looking at it, and by the way, in certain states, EPA standards for line noise or EMF in certain buildings, when you get ready to sell some real estate, this reading must be 100 or less on this meter, because EMF radiation is dangerous. If you round it up all day long, it's dangerous. It causes cancer and everything else. So if you were in certain states and you tried to sell this building, first thing the real estate person is going to tell you is you're going to have to get your line noise down to 100 or less before we can proceed with your sale. So we're a little high right now. This is what I'm calling line noise, and that's what we're going to concentrate on. This is a small little amp meter, and it's connected directly to this motor. And we turn this on, and we see it's running 5.8 amps. Turn this one on. This meter is going to represent your meter out battery showing 5.7 amps right now. Hope you can read that. 5.6. So they're pretty close. 5.8 right there. We turn this capacitor on, and immediately what we're going to see is an amp reduction at the meter down to 3.5, but you notice that the motor is still setting at 5.8 amps. In other words, we're not affecting this motor in any way. This motor gets exactly what it needs always. We're filtering it back toward the meter, and we're filtering out line noise. I don't know if you noticed, but our line noise went from 1,000 something down to 135. Let me turn that back off and watch the meters. Back 1,600 and something.
What's that represent again, the blue one?
Excuse me?
What's the blue one represent?
EMF, electromagnetic field.
Yeah.
Or line noise. I call it line noise. Microsurge. Another thing we do, what happens is when we condition the line going back, naturally we're saving electricity because if we're cutting the amperage in half, to give you an idea, if it's in the middle of July and I walked up to your house and you had your air conditioner running and I reached up and turned off your air conditioner breaker, we would lower the amperage on your panel box immediately. Do you think you would save electricity? Absolutely. The only problem is you'd be so hot it'd be miserable and it wouldn't be a good idea. We just did the same thing without turning off anything.
Took away what we don't need.
That's right. And now, there's another important thing that we talk about a lot, and that's called power factor. Power factor is the overall efficiency of the building, and that's how we measure it. Power factor is an accumulation of voltage, amps, kVA, all put together, and then we have a brand new number. That number is called power factor. It starts at 0.00 and it goes all the way up to 0.99. 0.99 is a perfect power factor, or a 1 is a perfect power factor. A lot of engineers will tell you to achieve a perfect power factor is impossible because that means there's virtually no load on your building. You turned off all
You're not using anything.
You're not using anything. In other words, the harmonics are in perfect balance with the amps, and the voltage are in perfect balance with each other, so there's no anything out of balance. Everything's perfectly balanced. Well, we're not going to be able to get a perfect balance on this particular little motor, but I am going to show you this. Our objective is to raise power factor to closest to a 9.9 that we can get it. Right now, this motor is running at a 0.28, which is really, really low in power factor. So the efficiency of this motor is not very efficient. So let's turn it on and see what we can do with power factor. It's at a 0.24, and it just went up to a 0.446. In other words, we almost doubled the power factor. We almost doubled the efficiency of this motor immediately. When we were in the building I was just talking about, we raised the power factor from a 0.08 to a 0.98. And I could have pushed it all the way up to a 9.9 if I wished with my sizing gear. But that's what sets us apart from the industry on these type of units. Now, let me say something about this guy right over here. Flip it up here so you can see it. This, we can walk into any building. Let me first explain something. You probably heard of Energy Star. You all heard of Energy Star appliances. What Energy Star appliances are is if you go to Lowe's and purchase a refrigerator, for instance, it's Energy Star rated and has a little seal on it. What that is, they've taken a machine similar to this and taken that refrigerator and put a sizing piece of gear on it and switched it until they found